All right, now in this video, I want to try to do 3 examples where you're trying to write the equation for a polynomial function. So here's one where, we're going backwards, okay? We know information about the polynomial, and we're trying to come up with the equation for it. So we know it's degree 3, so we're going to have 3 zeros, and we're going to write factors for each of those zeros. So here's our zeros. We have a 0 of 3. We have 1 of 5i. And then the third 0 is going to come from the fact that since this is imaginary, you're going to have another one paired up with it so that when you multiply everything out later, you won't have imaginary numbers for the coefficients. So even if they don't tell me about that negative 5i, I know it exists because they're imaginary. They have to come in these conjugate pairs. Okay, there's been a homework problem about that you've probably seen. So once you have the zeros, I want you to think about the factors. So 3 came from a factor of x minus 3. Similarly, 5i would come from x minus 5i. And then if the 0 is negative 5i, it must come from x plus 5i. See how the signs are kind of opposite? All right, now it's degree 3, and so there's my 3 factors. So I basically have my function at this point. I know f of x has to equal, but the one thing I don't know is it has to equal some number times these 3 factors. Okay? And so I'm going to use a letter A to stand for that. The rest of the problem is going to be us trying to figure out how to get the A. Okay? So that is like a separate piece of it in a way. So we've already used this information, right? We use that already. Okay, I should have done that in green because it's what we did with all the work in green. Okay. Now what we're going to do is we're going to take the information here. So if we know that f of 2 equals negative 58, then what we can do is plug in a 2 everywhere the x is located. Now we could have multiplied out first if we wanted to. Actually, I wish I had, so let me go ahead and erase that and do that first. Meant to do that. Okay. I'm going to do a little simplifying before I plug in. These 2 right here, I'll go ahead and FOIL out. Okay. And then don't forget I have the rest of this. I'm just not going to multiply it all through yet. So I'm going to finish simplifying and see how the i's cancel out there. And then the I squared right here, this I squared can be replaced with a negative 1. And don't forget you're multiplying at that point. So this becomes x squared minus 25 times negative 1 would be plus 25. Okay, so we get to there. And now what I'm going to do is I'm going to use the information about f of 2 being negative 58. Okay, so now I'm going to come in and do f of 2 equals, and I'm going to plug the 2 in everywhere there was an x. All right. And then I'm going to work that out because I know whatever that is, when that all works out, it's got to equal a negative 58. So this is negative 1. This is 4 plus 25, which is 29. Okay. Let's get rid of that guy for now. Okay. And so what I got right now is that negative 29a equals negative 58. And so when I divide that negative 29 out to figure out what a is, I come up with a being, that goes in there twice, doesn't it? Positive 2. Okay. Now, the rest of the problem is going to be cleaning this up, finishing it, so it's not in this like intermediate form. So what I'm going to do is I'm going to put the the formula back together. So we have f of x equals 2, and then get your variables back in there, the x minus 3 and the x squared plus 25. All this work was just trying to find a. Now we're going to plug that a back in to the formula we had earlier. All right, so now I'm going to finish it up by just finishing all the multiplying. So I'm going to FOIL these guys out, and I'll get an x to the third minus 3x squared plus 25x minus 75. So I multiplied them out, but don't write it like that. Don't forget that that's grouped. That 2 has to actually get distributed throughout. So you'll have 2x to the third minus 6x squared plus 50x, and then minus 150, okay? And so when they say find a polynomial, they want you to come up with what the formula must have been, and they just had given you some information about it. So this would be your final answer. And on my math lab, they might give you this part already, so you may just be putting in the worked out formula, okay? All right, I want to do another one of those. I want to do one that involves a graph, and I'm going to try to get these on the same video because they're the same concept. Okay, this is almost exactly like the previous one in a way. It's giving you some information about the polynomial in the picture. And so like looking at that, I can tell what the zeros are because the zeros are x-intercepts. So there's a 0 at -5 and there's 1 at 3, okay? All right, so these are going to help me get the factors of my formula. So the -5 will correspond to an x plus 5 factor. The 3 would correspond to an x minus 3 factor. Okay, now consider the behavior, the multiplicity, right? Multiplicity. It's the behavior at the zeros. It comes from the behavior at the zeros, okay? So do you see how at 3 kind of looks like a parabola? And how at the -5, it's like a line. It's behaving like a line would. So the factor associated with the 0 of -5 has multiplicity 1. This one, the factor associated with the 0 of 3, should have an exponent of 2 on it, okay? All right. Now, what we're going to do at this point is kind of see where we're at. So what we know right now is that our polynomial is going to be some number, some adjustment factor, and then x plus 5 to the first and x minus 3 to the second. Now, what they did is they gave me one other piece of information that was kind of camouflaged. But remember on the previous problem where they gave me this information? Well, and that was like an ordered pair. You know, that would be like an ordered pair with an x of 2 and a y of -58. Well, on this problem, that's what the 0, 9 really is. It's given me a piece of information. See, that 0, 9 really is saying that f of 0 equals 9. All right, so what you're going to do down here is you're going to plug in the 0 for the x. And when you do, you should wind up getting 9. So that's 5. That's -3 in parentheses squared, which would be 9. So you have 45a equals 9, which means the a turns out to be a fifth, doesn't it? Okay. All right, so we're almost home free. Do not know why that moved so far down. Let me erase that. Okay. Put the 5 back in. All right, so we're really almost home free. All we got to do to finish this up is we have to go back to our formula, plug in the 1/5, but keep the x's on the factors on the rest of it, and this would be your polynomial in factored form. Now we multiplied the other one out because it had the imaginary numbers in it, and the directions wanted you to find or show you had a polynomial with real coefficients. Most of the time we're going to be okay with it in factored form. Okay. So I'm just going to stop there. Otherwise I'd have to do a lot of multiplying out, and sometimes I have to, but you can handle that part, I'm sure. Okay. All right, I wanted to do one more, and I'm doing this one to tell you how to handle the multiplicity thing when it's given to you in words. This is almost exactly like the previous problem. All right, so let's picture this. Even though we don't need a graph of it, that's not the point of it. Let's picture it so you can compare it to the other one. We have a 0 of 0. We have a 0 of 1. The 0 of 1 has multiplicity too, it says. That just means it's going to bounce there. It's going to touch and turn, okay? And I don't really know how it's working. I don't know whether it's going to do it from the top like that, or whether it's going to come from the bottom, and I don't know how steep it is either. I don't know my adjustment factor, okay? But what I do know is it crosses at 0, crosses the x-axis at 0, and it crosses the x-axis at 1. So the 0, okay, if you have a 0 of 0, that corresponds to a factor of x. You could think of it like x minus 0, but it's really just a factor of x. And then a 0 of 1 would correspond to a factor of x minus 1, okay? So we have an x minus 1, okay? Now, when they said multiplicity 2, that was just telling you to put an exponent of 2 on that factor. So we basically have our equation. Here it is, but I need to figure out the adjustment factor. And that's when we're going to go back in and use that little added piece of information. F of 2, if I plug a 2 in, everywhere there is an x, I should wind up getting an 8 out. So this is a 2, this is a 1, 2 times 1, that's 2a equals 8. And when you divide by 2, you can see that a would be 4. Okay? So we're almost finished. What we got to do at this point is plug that 4 back in right up here. Okay? And we'll have the formula. F of x equals 4x times the x minus 1 squared. All right, that would be the factored form. And then if they wanted it multiplied out, you would just be sure to write that twice. So this right here is normally okay. I prefer it. So if I could control it, I would do that all the time. And then if you need it multiplied out, I recommend you FOIL that first. It's 1x minus, it's minus 1x minus another 1x plus 1. And then take the 4x and distribute it throughout. And you see how it turned out having degree 3. And that would be with it all multiplied out, okay? And usually either one of those is considered okay. All right, let me stop this so it doesn't get over the limit I have, and I'll get these things posted.